Okay, unless you've been absent, you should have already made this with your chemistry teacher, the ionic versus covalent foldable. Today we're going to look at our Unit 4 homework using this, pages 3, 4, and 5. Okay, so using only our covalent rules here, we're writing formulas for covalent compounds. Now you're going to need to memorize all of these prefixes, but in the meantime, here they are, you wrote them at the top of your page. Okay, writing formulas for ionic rules, right? When we write formulas with ionic, it's your 4-step formulas, symbols, charges, crisscross, reduce, and erase. We've been doing it for a long time. When we're doing it for covalent, you just translate. The prefix in front becomes a number in back. No crisscross, no reduce, much easier, as long as you don't mix the rules up, okay? So looking down here then, disilicon hexabromide. Let me scoot for you. So di is 2 and hexa is 6. So I'm going to say silicon 2 and bromine 6, like that. Now you could reduce this, but we don't in covalent. You don't reduce them. Okay, that's it. The numbers in front, di, becomes the number in back. Okay, so tricarbon, the prefix in front becomes number in back. So carbon 3, octa 8, C3H8. Done. Don't crisscross, don't reduce. Yeah, but charges are ions, right? A charge is an ion. So we only worry about charges when it's ionic. Hexa is 6, deca is 10. So hexacarbon, decahydride, di is 2, tetra is 6. So you'll notice we don't say tetra oxide. When it's oxygen, we drop the vowel at the end, so tetroxide. Okay, but it still means tetra. Oh, and you know what? Tetra is 4. Come on home. Dinitrogen, tetra, O4, like that. Okay, very good. Let's look down here at the bottom then. Okay, what is the formula of disulfur hexoxide? So di is 2, hex is 6, because it's hexa. Okay, so sulfur 2, oxygen 6. That's your answer, A. You don't crisscross. That's the problem with B. You don't reduce when it's covalent. That's the problem with C. And I don't know what's wrong with D. Okay. And then number 16 is vocab that's really essential. 2 atoms will share electrons in what type of bond? Okay, well it's not D. Metallic is the weird delocalized. You don't really have to worry about that for testing. But ionics transfer electrons, covalence sharing is carrying. So you will share electrons in a covalent bond. Let's come over here to 4. Okay. On page 4, okay, we're doing the opposite. Instead of writing the formula, I'm giving you the covalent formulas and you're telling me the name. Okay? So the first name, you just take the number and make it the prefix, except for mono. Okay? So only the second element, or high schoolers that share water bottles, haha, get mono. Okay. So instead of I7, I'm going to use the prefix for 7, which you should have memorized, but I'll put it there for you because it's still early in the unit. So hepta, iodine, and then Br4, I'm going to take the number in back and make it a prefix in front and say tetra bromide. Okay, so you'll notice I only changed the last 3 letters to ide. You don't change the first name. So heptaiodine, tetrabromide. Okay, sulfur and chlorine, 3 sulfurs. We're going to call it trisulfur. S-U-L-F-U-R. Okay, it's not the second name, so I don't call it trisulfide. Okay. I'm going to go Cl5 is 5 chlorines, penta. And since this is the second element, I'm going to call that one chloride. Okay? Trisulfur, pentachloride. P4 is 4 phosphorus, so tetraphosphorus. H-O-S-P-H-O-R-O-U-S. That's a long one. Tetraphosphorus. 6 nitrogens is hexa, and since it's the last one, instead of hexanitrogen, hexanitride. N-I-T-R-I-D-E, and I ran out of room. That's okay. For this last one, 1 selenium. I do not call it monoselenium because I never put M-O-N-O as the first 4 letters. So I'm just going to call it selenium. Okay. S8, octasulfide. Okay. And if you'll look up here at these examples, okay, like I was saying on number 32, you never would say monocarbon monosilicide. The first element cannot get mono as part of its name, but if there's only one on the second one, you have to say mono. Okay. So invisible mono in front, carbon, and then monosilicide. You'll get lots of practice at this, trust me, and you'll get really good at it. All right, now it's about to get real. Mixed naming. So some of these are ionic, which means 4-step formulas, and some of them are covalent, which means you just translate. So I'm going to use different colors. If it's covalent, I'm going to use a blue pen. If it's ionic, I'm going to use a red pen. Okay? And it is your job to figure it out. So if you see any prefixes, like on 31, trisulfur tetroxide, I know this one is covalent because I've got prefixes and because they're both nonmetals. So I will only be using my covalent rules for formulas, which is just translate. Okay? So trisulfur is 3 sulfurs, S3. Tetroxide is tetra, so I'm going to say O4. Easy peasy. Chromium 3 hydroxide. 2 ways to know that this one is ionic. First, you only get Roman numerals if it's ionic. There are no prefixes, and chromium is a metal. So that should be a lot of hints that we're using only the ionic rules. And ionic formulas have to be 4-step formulas. Okay? So I'm going to show my work over here. Chromium and hydroxide. Okay, my symbols. Chromium making a 3 charge. Hydroxide is a polyatomic ion. So I'm going to grab my list and show you that it makes a -1 charge there. Symbols, charges, crisscross, reduce and erase. So Cr, invisible 1, OH, 3, like that. Okay. Fluorine pentachloride. I know this one must be covalent, excuse me, because there's a prefix and because there's no metals. They're only nonmetals. So if it just says fluorine, let me pull my list up again for you. If it just says fluorine, I know it's just mono, but invisible. So let's get to blue, covalent. Fluorine with no prefix is just fluorine with no subscript. Pentachloride means 5 chlorines. And then lead 3 sulfates. This must be ionic because lead is a metal, because there's a Roman numeral, and because there are no prefixes. 4-step formula. Lead sulfate is SO4, which makes a -2 charge. Lead making a 3 charge. Okay, so there's symbols, charges. Crisscross, reduce and erase. Pb2, SO4, 3. Do we have to show our work? Yeah, if you want to be correct, you do. Probably. You might be almost right if you don't show your work, but almost right is wrong. Yes, show your 4-step formulas. You don't make mistakes. Okay. Again, when we're naming, we're mixed. So it warns you to be careful. Some are covalent, some are ionic, and if it's ionic, some of them need Roman numerals. So ALN. The only way to know if it's ionic or covalent is by checking. So ionic things are on both sides of the periodic table. That's my little memory device. Ionic has at least something from over here, a metal, and something from over here, non-metal. If it's covalent, like if we're doing YMCA, we'd be pointing this way only. Okay, so only non-metals in it. Aluminum is metal. Okay, nitrogen is a nonmetal, which tells me I'm staying in red because this one's ionic. Okay, now I need to check if it's ionic. Does it need a Roman numeral? Oh, good. Aluminum's in the exception block, so it's just aluminum. And nitrogen, we make nitride. Do not call this aluminum mononitride. You do not use prefixes if it's ionic. Okay? Phosphorus and fluorine are both nonmetals. So they're both on that side, which makes it covalent. So I do use the covalent prefixes. Okay? 6 is hexaphosphorus. Oops, I should switch colors, remember? Okay, because covalent, hexaphosphorus, ORHS, and then 7 is heptafluoride. That's a long name. Fluoride, F-L-U-O-R-I-D-E. I spell that wrong all the time. Heptafluoride. CN. Let's check. Both nonmetals. Both over there. Covalent. So prefixes, not monocarbon because it's in front. Just carbon. And then there's one nitrogen, but the second name has to have mono if there's only one. So mono nitride. One carbon, one nitrogen. We're going to get practice. We're going to need practice. Don't fall behind on your homework, okay? And then just come in for Eagle's Nest and tutorials if you need it. We all want you to be successful. Thanks, y'all.